Billions of years ago, Mars was not the frozen desert we see today. It had a thicker atmosphere, flowing water across its surface, and conditions that may have supported life. So what happened? How did the red planet transform from warm and wet to cold and dry? Since 2015, NASA's Maven mission has been searching for answers high above Mars, studying the planet's upper atmosphere to understand how it slowly escaped into space. Now, for the first time, Maven has created a global map of high-altitude winds roughly 200 kilometers above the Martian surface. To accomplish this, the spacecraft dips into the upper atmosphere during the closest part of its orbit. There, an instrument called NGIM samples atmospheric particles, measuring their composition and motion. By rotating the instrument, Maven determines wind speed and direction along its flight path. As the spacecraft's orbit gradually shifts over time, it scans different regions of Mars across multiple seasons and times of day. Over 4 years, these passes formed a web of observations across the planet. The result is the first ever global map of wind circulation at such high altitude on any planet beyond Earth. But the most surprising discovery lies far below. Scientists found that high-altitude winds carry imprints of Mars's rugged terrain. Above the Tharsis Plateau, home to Giant Shield, volcanoes twice the height of Mount Everest, winds were seen diverting around elevated regions. Near the surface, winds are forced over mountains and across valleys. These disturbances travel upward as gravity waves. When they reach the upper atmosphere, they disrupt high-altitude winds, altering their flow. From the edge of space, Maven can sense the hidden presence of mountains far below. These measurements do more than map modern winds. They help explain how energy moves through the atmosphere and how particles are heated and lost to space. Over billions of years, solar radiation and the solar wind stripped away much of Mars' atmosphere, thinning it until liquid water could no longer remain stable on the surface. Without a strong global magnetic field to protect it, Mars became vulnerable to this slow atmospheric erosion. By understanding Mars today, scientists are reconstructing its ancient climate and uncovering how a once potentially habitable world became the cold desert we see now. High above Mars, skimming the edge of space, Maven is not just measuring the wind. It is revealing the story of a planet's dramatic transformation. Thank you for watching Voyage to Void, and join us on the next journey into the universe.